Hey everybody, welcome back to EveryLastByte. And so we're in episode 3 now, and basically in the last episode we talked a little bit more about how the chip is actually making its interacting with the physical world. We said it's got a bunch of features, and basically it's got a processor, and the processor interacts with memory, and then interacts with some of its features, which then are directly connected to the pins. So today we're going to look at just the blink sketch, and we're going to kind of see a little bit more about how that actually happens. So what we've got here is the Arduino board, and of course you got to keep in mind that there are electrical connections from the pins that are here on the chip itself to the header pins that are out here. So of course you can plug your electronic circuit into these guys on the top and bottom, and those are mapped to the pins that are over here. It's not quite one-to-one, so 0 is not going to be this corner, 1 is not going to be over there. It's a little bit spread out, and the designers did that for distinct reasons that we'll probably talk about later. But just have an understanding that these guys are wired physically to these pins out here and down here at the bottom. So to kind of get a closer picture as to what's going on beneath the surface, we're going to crack it open again, crack that chip open. And again, we have the CPU, but now I've kind of highlighted something that's I want to bring up, which is going to be the port D in this case. So port D is basically what you write to when you want to turn a pin on and off. So what's happening is that port D basically is wired physically to a group of 8 pins. Port B is actually also wired to 8 pins, and port C is wired to 7 over here. So these ports are basically groups of pins, in a sense, or groups of ways of interacting with those pins. And so what the processor can do is it has a direct line of communication with this its creature port D, and then it can actually kind of toggle some of the switches inside of port D, and then port D will then turn on and off some of the pins that's actually connected to. So just to look at port D in a little bit more detail, you can kind of imagine that those switches are kind of like little boxes living inside of port D. And if I put, I can put 2 values in here. If I put a 0, then that pin will be off. If I put a 1, then that pin will be on. And that's the only thing I can actually put into these boxes, either 0 or 1. So this is kind of oversimplifying it, of course. It's actually a little bit more complicated. Not only is there port D, there's also 2 other things that are connected to port D, and that's DDR-D and pin D. So this is the data direction register, and this is port D is what's actually what you write to turn things on. This is going to tell you whether or not that pin's going to be an input and output, or an output, and then pin D over here is the raw value. So you can say I want pin 0 to be an output, so I'll put a 1 there, and then I want to write to it, and I want to turn it off, and so I can put a 0 here, and because this is wired as an output, this will be 0 here. You can then say, okay, I want to turn it on, put a 1 here, and then because this is still an output, this is going to be 1 here. And at any moment in time, I can go back and look at the value over here, which is going to tell me basically what the raw value is on this group of pins over here. And so namely, because I just turning this one on and off, if I wanted to look at that one, then I'd go over here and say, what's pin D0? And it'll tell me what the raw value is. So I can kind of turn something on and actually check and make sure that I turned it on if I wanted to. So yeah, this is kind of exposing a little bit more about what's going on with directly turning on and off pins. And so if you kind of box this all up, you can kind of box that up and go back to port D over here. And then of course the processor is the one who's in charge of port D, and of course we're the ones who are in charge of programming the processor. Well, we're dumping a program into memory which the processor reads, and then the processor can interact with the port, which can then interact with the pins. And so to kind of go full circle, we'll do a quick example. Okay, so over here we've got the Arduino. We got the blink sketch. Just turn an LED on for 1,000 milliseconds, turn it off for 1,000 milliseconds, and then this thing's repeating itself once every 2 seconds. And so this is just the default blink sketch, and it's running right now. And in case you don't believe me, I can upload it again one more time. So yeah, it's blinking once every 2 seconds. That's nice, but what we'd like to do is we'd like to kind of break apart and kind of expose what's actually going on over here. And so pin mode is actually doing some interaction with the LED that's connected to whatever port that's connected to inside. So I'm going to kind of move this over to the background and pop open what's actually going on inside, and we can read this side to side. Pin mode is actually saying is interacting with that pin register I was talking about earlier. And then we can go over here to digital write, and now we're going to say pin 13, we're going to turn it on. We're going to wait some time, and then we're going to turn it off, and we're going to wait some time. So this digital write here and here is actually interacting with port D. Actually, it's not port D, it's another port. But it's interacting with the port directly. So if we go back to the diagram, we can kind of trace that full circle and say, okay, the processor is reading some instructions from memory. It's going over, it's turning on, it's setting, in pin mode, it's setting one of these pins to be an output, and then it's setting one of these pins over here, or sorry, one of these boxes, I guess, to be a 0 or 1, whether or not it wants to turn the LED on or off. So, going back over here, if we look on the right-hand side, this sketch basically does the same thing. Just kind of a more raw down to the hardware level. DDR-B, that's data direction register B, that's saying that I want pin 5 to be an output on port B. So if you look at, this is just a number encoded in binary, it's just a byte. And so if you look, these go from most significant bit first to least, and so that basically means this is this here on the right is going to be pin 7. It's pin 7, 6, 5, 4, 3, 2, 1, 0. And in computer science, we start counting at 0. So we're going to say this is pin 0, and then to the left is pin 7. And that's a group of 8 pins. So 0, 1, 2, 3, 4, 5. That's going to be an output basically. And so if I look over at the schematic of Arduino, I didn't pull it up. So you gotta trust me on this one. The LED pin, which you talk to at a high level as pin 13, actually maps over to port B5. And so what we've done is we've made it an output here. And then what we're gonna do is we're gonna turn it on by writing a 1 to the port. We're gonna wait a little amount of time. I'm just delaying 50 milliseconds right here. And then we're gonna turn it off. We're actually turning all of them off, but we're gonna turn that one off. And then we're going to delay a little bit more. And so if we kind of add these two together, there's actually 500 milliseconds. So it's going to blink a little faster. But what we want to highlight is just that we're talking to the hardware directly. And then the reason it's blinking faster is so we can tell the difference between the two sketches. So I'll pop that one open and upload that one just to make sure I'm telling the truth. And there we go, we're blinking a little faster. And that's pretty much it for this tutorial. It's kind of just like going full circle and saying, okay, we've got the processor, it's got features, and it's got, where's that picture? Yeah, so there's the processor, it's got a bunch of features, and today we just kind of talked about just turning LEDs, or turning pins on and off, which is talking to the ports on the outside. And that kind of pretty much sums it up for today. So yeah, stay tuned, and we'll keep going.